people say, oh, you're a computationalist because you think machines have consciousness. No, I'm an anti-computationalist. I think they may well, but it won't be because of the algorithm. It will be because of whatever they're doing in spite of the algorithm. Bubble sort is interesting because it does things in spite of the algorithm, not because of the algorithm. It's what's the space? What else is there between the chance and necessity? What else can it do, right? So I look at these model systems and I say, asking it whether it's conscious is completely useless because in biology, evolution made sure that the things we talk about are grounded to the things we actually care about. Right? You have. I mean, yes, there are spies and there are, psychopaths and whatever, where the things they talk about are totally, total garbage. But mostly, it's a pretty good guy, right? We've now created something where the thing we force it to do might have zero to do with what it actually wants to do. The thing that bubble sort does is not that's interesting is not sorting. It has nothing to do with sorting, and so I suspect that whatever properties language models have, whether I don't know what degree of cognition they have, we haven't tested this yet, but whatever degree they have, it's not going to be because they talk. I think it's going to have zero to do with the language. I think the language might be a complete right. I think the language might be a complete red herring. You can ask them about their consciousness all day long. You are not going to see what the intrinsic motivations are.
So hi everyone, my name is Balázs Kegel, and this is the iScientist podcast where we explore artificial intelligence, the body and the soul. And this is my great pleasure to host Michael Levin the second time. Michael is the developmental biologist from Tufts University. And we had 1 hour the other time, and since we spoke, I spoke to Mark Solms and Kevin Mitchell and Alexander Bard again. And those were very inspiring conversations that I will bring up here.
Sure.
So how are you today, Michael?
I'm good. Thanks for being back with me. Yeah, it's good to see you.
Good to see you. Yeah, so today I want to talk about a little bit what I would label as your Platonic turn and AI. Because I'm completely with you on nested agency. I'm with you on these different organisms that are all collective intelligences that solve problems in different spaces. I have no problem imagining morphospace or chemical space or even an anthropologic space if we go above. But your turn to patterns and sort of like the superiority of patterns in all this ontology, that surprised me. So first question would be, how did you arrive to that, and what was your thought process? I think it's a relatively recent thing, no?
Well, to be honest, no, I've thought about these things for decades, but I have a little, I have a bit of a policy that I try not to talk about things until they become actionable. So it's very cheap to have ideas and think big thoughts and whatever. Anybody can do it, but it doesn't help until you have some way of doing something useful with it or to have some strong argument for it. And so I've never brought this up until this year. I never mentioned it because it wasn't needed for our work. It wasn't anything I could say anything strongly about. I couldn't demonstrate any new way of. I mean, it's hard to improve on Pythagoras and Plato and whatever. So I didn't say anything about it for years. This year, I'm talking about it because I think we are now to the point where this has become very actionable. It now matters for laboratory research. It now matters for guiding how research is going. It's not just philosophy. It's a very practical choice for science and engineering. And so now we can talk about it. And so I also just want to be clear. I called it Platonic space, and I knew there were pros and cons to this choice. And at some point I may need to change the name of what I'm talking about. The upside of it is that immediately the mathematicians know what I mean. And this means that it's very clear that I'm not saying I made this up. This is not my invention. This is something that many working scientists in mathematics already have this concept, and it ties into existing work, which I think is very important. Is not just to make up new terminology without connecting it to what's going on. However, the downside is that my vision of what's going on here, the current model, which I'm sure will change 100 times going forward, but the current model is really not quite what it's really not quite what how I think Plato thought about this. And so by calling it Platonic space, I am not trying to stick to the original view to whatever extent we know what it is. My goal is not to say that Plato is right or any of that stuff. I take responsibility for whatever is wrong with my model, but I think it's different than what people were saying before. And so that it has pluses and minuses, and we'll see if I have to rename it later.
Yeah, so can you elaborate a little bit what it is about? So the main point being is that it seems like you're saying that that space is superior to the biological space where things are implemented, and sort of like what I would call the patterns are calling the shots. Am I saying it correctly?
Well, let's okay. So let me go through a little bit of an argument of how I got here, and I want to point people to two things. There's a preprint, which is a chapter that I wrote for a book, and I'll give you the link to it later. That goes over all this in great detail. And there's also a symposium that is currently ongoing. It's an asynchronous symposium happening all the fall. It is. I'll give you a link to that too. There are some amazing talks that have already been given, and many more will be given from mathematicians, computer scientists, philosophers, biologists on the topic on this topic. Some of them being critical of it, some of it showing their work in it, because there are many people actually coming to this view now, especially in machine learning and things like that. So so people who are interested in other views besides mine can go to this symposium and see what's going on. So let's talk about a couple of examples, and then I'll kind of describe how I put them together. So the first example is something like there are many of these, but let's look at cicadas. Okay, so we got this insect, and they sleep for either 13 or 17 years, and then they come out. So if you're a biologist and you would like to understand what's going on here, you might eventually realize that the reason this is happening is because they're trying to time it so that the predators don't get them. Because if it was 12 years, then every 2-year, 3-year, 4-year, 6-year predator would be timed with them, right? And so you say, okay, that's amazing. That's a very good choice. Why 13 and 17? What is special? And then you find out that, oh, well, these are prime numbers. And so what does that mean? Why are these prime numbers instead of some other number? And now you have left the Department of Biology. You are now in the math department. If you would like to understand why 13 and 17, you're not going to get that answer from biology. You're not going to get that answer from physics. You need to talk to the mathematicians and understand something about the distribution of primes. And by the way, I'm no mathematician. This is just how I understand these things. So there are many examples of this. Because biology, I think, exploits all of these interesting facts of mathematics and computation. There are many of these weird sorts of facts. It exploits them greatly. And when you want to understand what's going on, eventually, much like in physics, you go down and you say, wait, why do the bosons do this or that? And the answer is, oh, because there's this mathematical object and it has a symmetry that only has two, whatever, like that's why they can only be in two. Eventually, when you drill down, as far as I can tell, you always end up in the math department. The explanation for why is this the way it is, the answer is because this mathematical object is like this. And the interesting thing about that is that for some of those patterns, there is nothing you can do in the physical world to change them. So the value of E, the natural logarithm, Feigenbaum's constant that governs a certain chaotic phenomena, you can tweak all the constants at the Big Bang, all the constants of physics. You can, whatever you want to do in this physical world, you will never change those things. And this is the kind of thing that was already obvious to Pythagoras and many people before him. And so in that sense, so what are we building here? In that sense, first of all, when you say who's calling the shots, to me, the answer to who's calling the shots questions, because it has to be a functional experiment. Can I tweak thing A and see a change in B, or can I tweak thing B and see a change in A? And whichever, right, that will tell you, right? And when you look at physics and biology and math, you can, if you were to change the math, all of the physics and the biology would change, but not the other way around. And so to some extent, I think, and I understand there are other, some people think math is constructed and that humans invent it and stuff. We can talk about that a little bit. But as far as I can tell, when you want an explanation of why things happen, eventually you end up in certain properties of mathematical objects. And the final thing I want to say is this, and this is why it is now very actionable, why these ideas actually make a difference now. In biology, when we want to understand why a certain living thing is the way it is, the standard answer, but biologists love two kinds of explanations, right? One explanation is history. This is the way it is because there's a history of selection. Everything else died out. This is what's left. There you go. That's why this is the way it is. There was a very specific environment that led to everything else not being as fit. So now you have this. So there's a sense of history. And the other thing they like is physics. Oh, because it has to minimize surface area, so therefore it's shaped like this, or it has to, some kind of physics principle that says it has to be like this. Okay. So now, so let's look at selection as an explanatory feature. We make Anthrobots. Anthrobots are these self-motile constructs that self-assemble from genetically normal human cells. They have 9,000 differentially expressed genes, so they have a very specific transcriptome that's completely different than half the genome is differently expressed than the genome in the body. They have 4 different behaviors that they can do with specific probabilities of transition among these behaviors. Not 7, not 1, not 0, 4, exactly 4. They have weird capabilities, like they can heal neural wounds. So if you put them on the bed of neurons, right? Okay, there have never been any Anthrobots. They don't look like any stage of human development. They don't look like any past, ancestor of ours that we know about. We, as biologists, we would like to do 2 things. We'd like to understand where did these very specific things come from. And it's not enough to say, well, cells like to stick together. That's great, but why this transcriptome? Why 4 behaviors? Why healing the neural wounds? Like, you have to explain the specifics. So, we need to understand why this is happening. And as bioengineers, we would like to say, okay, but if I wanted something different, what would I have to do? In order to do that, again, you have to understand, where do these things come from? Where do the possible behaviors come from? So now you have 2 choices. You have 2 choices. Choice number one is and this is what most people say to me when I say, hey, how come, isn't it amazing that random gene regulatory networks can do 6 different kinds of learning, including Pavlovian conditioning? Like, why does that work? And people say, well, that's just a fact that holds in our world. It's just a fact that holds. Now, the benefit of that position is you get to have a nice sparse ontology. You can say the physical world is all there is. It's full of surprises. It's emergent. That's what people say. It's emergent, which just means you got surprised. It means you didn't see this coming, like, fine. And so lots of surprises. We'll write them down in our big book of emergent things, and that'll be that. But the downside is, I think this is very pessimistic. I think this is a Mysterian view, to think that these are random things that just happen to hold, and that when you come across them, you can be surprised, and that's that. I prefer the way the way at least some mathematicians look at it, which is to say, let's assume this is not a random set. Let's assume that there's a structured latent space of possible outcomes, and that what we can do is systematically study. So now here's the research program. And when I give talks about this, I show my last slide is like 12 things we're doing to actually research this. That's why I'm talking about it now, because it's become actionable. We can systematically study that space and find out what the possibilities are, what structure do they have, and which of them you're going to see when you make specific interfaces. And so I believe that everything we make in this world, the embryos, cells, robots, language models, like whatever, machines, whatever, everything you make is an interface that pulls down some set of patterns from this latent space. And really, if you want to be very minimal about it, my claim is really very boring and very minimal. It's simply that it's not a random grab bag of surprises. it's a structured latent space that we can study. That's it. That doesn't seem terribly outrageous to me, that to assume that there's going to be some structure to these things. And then I can layer some weird stuff on top of this that's much more, sort of controversial even than that. But that's the basic, that's my basic point.
I think there is nothing controversial about the structure of that space and the existence of this abstraction that we've been using for thousands of years. What I'm wondering is, so whenever I have this kind of problem, like in biology, you have this circular causation, where you say it's emergence is not enough. You also have emanation, and you have these organisms that seem to have caused by themselves, sort of. And inside, if you look at the dynamic processes, you have this causes that, and that causes this. So you have this circularity. And what I like to imagine or say in these cases is what John Vervaeke calls transjective. So it's neither one causes the other, nor the other causes one, but they sort of like realize themselves. And so when I think about the Platonic space and the let's say the morphospace, for me, nobody's calling the shots. They realize each other in a certain way, which is less idealistic for me, and I somehow feel better when I think about this.
Well, I can agree with 90% of that, which is that I don't think that the contents of that space is fixed and eternal. I actually think that it is plastic, and that by ingressing into the physical world, the forms, the patterns change. The patterns are, they're modified by their experiences through the physical world, and I think there is a bidirectional causality here. I agree with that. However, the part that I would point out is two things. One is, what you and I can agree on this kind of bidirectional thing, but that still doesn't make people who are physicalists, that still doesn't make them happy, because they don't want another space. They want the physical world to be all there is. And so we haven't made them happy by saying it's a bidirectional kind of causality, right? And the other thing I just want to point out is this. You can watch one of the talks on that in that symposium is Alexei Tolchinsky, and he asks some really good questions about this, and in particular he critiques this idea, saying that, look, concepts are constructed, right? That we learn what is an apple or a bird or an airplane. That these things, like, it's hard to. I get where he's coming from. He's saying it's hard to think that somewhere in Platonic space there's this thing that's called a Boeing, a Boeing 747, and that this is like that these things are in some way constructed by us. And I share that intuition. I think that we certainly can modify the contents of that space and construct new residents of that space, so to speak. And so that's fine. But I think we have to come to grips with the fact that while we do, as a cultural kind of a process, create certain kinds of forms, whatever the xenobots that we're doing, no human put that there.
No.
Okay, this does not come from human culture. No human decided what the value of Feigenbaum's constant was going to be. There are things that are discovered, not constructed. And I think overall there are many things that are both.
Exactly,
right?
that's realization is both at the same time.
Yes, I'm completely okay with that. But I can't go the full way to say that the whole thing is constructed by us, because it's very clear to me that there are patterns that are not.
No, that would be the sort of physicalist extreme. But some critics say that you become again reductionist in the other way around, like in the idealist way around, by saying that the patterns are primary or superior, or they are calling the shots. You see?
Well, I mean, yes, I see, and there is also this notion of, as an engineer, I mean, this is a very simple engineering approach. Is like, if I want to know what's calling the shots, what I'm really asking is, I'm not asking complex questions about. So for example, Chris Fields had a useful critique too. He said, well, causes and effects have a time order to them, The cause is supposed to precede the effect.
Yes.
And how are you going
No
to
time.
how are you going to put the Platonic patterns in the cause-effect relationship? And so my point is, I have a very engineering approach to this. I'm not trying to unravel a philosophical story of causation. That's beyond my pay grade. What I want to know as an engineer is this: which control knob do I tweak to make things happen? That's it. That's it. And I know that I don't have a control knob that will change the value of E, but I do know that if the prime number distribution was somehow different, the cicadas would be coming out at different years. And so there seems to be, I don't know anything about the time order. I don't know when the value of V was set, before the creation of the universe. I don't know any of that. What seems to me is that if I want to understand what controls what, I need to understand the contents of that space, because it's going to impact what I see when I make certain interfaces. And in particular, I mean, we're doing some, I can even share with you some slides of when I talk about the research program we have. One of the big themes that keeps coming up again and again in our work, and there's some papers that are going to be coming out in the next few months on this. There's this very strong theme of getting more out than you put in, right? And even some of this is coming up now in computer science as well. It's showing up in the properties of random ANNs and things like that. It's very clear that when you make certain kinds of interfaces, you get way more out than you put in. And this notion of algorithms, of I wrote an algorithm and it's doing what I said, and I expended this much effort and this much is happening. Yeah, there's a lot more happening than what we put in for effort. And that's, it's just for, as an engineer, just an accounting of the effort is what I'm interested in. And look at the computational, like we can ask, when did you pay the computational cost of designing a frog, for example? Well, that's easy. The eons of time where the frog genome bashed against the environment and where, okay, when did you pay the computational cost of designing the Xenobot or the Anthrobot? Never. There's never been it's never happened. There haven't been any. It came out the day we made them. There it was, right? So we have to there needs to be an accounting of where the effort is coming from. And actually, I have one of the craziest ideas I have, and you'll see hopefully soon some of the applications. That Platonic space, I think, not only is it not fixed, meaning that it's a bidirectional relationship, but I think it offers more than static patterns. I actually think it offers compute as well. And I think I know this is like, it sounds completely nuts, but I think we can actually do compute in that space that isn't paid for in this space with the standard, the cost of bits and all.
No, I can see that it's the agency where I have a difference. And so what I would like to ask you is, do you think these patterns have agency? Do they have internal world? Do they feel? Because this like if I ask Mark Solms, like feeling is an important part of being conscious.
Yeah.
Okay, it's not exactly the same as agency, but for this conversation, let's say recognize something.
Yeah, I would turn that whole thing 180 degrees. I would say patterns don't have agency. Patterns are the agents. I don't believe that there are physical objects that have agency, and then the patterns may or may not have it too. We as far as I can see, we are patterns. Now we have two ways we can look outwards into the physical world and see each other, through this physical interface, but the actual agency is on the side of it's on the other side. It's on the side of the patterns. We have agency to whatever extent, and I can kind of explain why I think that. Because look, I don't know if I don't remember if last time did we talk about the creatures from the center of the earth? Did we talk about this stuff?
No, I don't think so.
So I'm adapting an old science fiction story just to erase this distinction between physical agents that process passive data, and then there's like information patterns in media that is passive, and then we process it. So imagine some creatures, they come out of the center of the earth. They are incredibly dense. They live down in the core. They're like super dense. They use gamma rays for vision, whatever. So they come up to the surface. What do they see? Well, none of this stuff are none of these things are objects to them. They say, you know, and one of them is a scientist, and he says, okay, well, this the surface is covered in like this very thin plasma, you know, this like thin gas, and he's got a device that lets you watch it, and he says, you know, there are patterns in this gas that sort of are moving around, and they kind of hold themselves together for a little while. They almost look like they're agents. They almost look like they're doing things. And the others say, well, you're crazy because we are actual beings. Patterns in the gas can't be agents. They're just patterns. I mean, how long do they live anyway? And he says, well, the patterns, you know, they hold together for about 100 years. And that's crazy. That's like, you know, those are like whirlpools in water. That's not anything. So a little bit, we have to understand we are also metabolic, our bodies anyway, are metabolic patterns. We hold together for some amount of time. The distinction between patterns and agents, between thoughts and thinkers, and Chris Fields and I have a paper on this now, and they're like erasing that distinction between thoughts and thinkers. And so I think that most of the action in terms of real agency is in the nature of the pattern. And this is what I'm saying. Imagine this Platonic space. What lives there? Well, there's some stuff that lives there that is really amenable to very formal kinds of models. And we call that the study of those kinds of things. Mathematicians do it. We call it math. And really math I will define as the behavior, it's a branch of behavior science. I think all sciences are a branch of behavior. I don't put physics on the bottom. I put behavior science on the bottom. Math is a very particular corner of behavioral science that studies very simple things. Now, since I've said that, I've been challenged by a mathematician who's going to give a talk at the symposium, who actually says that I'm being too you know, which I love, that I'm being too conservative, and that actually in their own world the objects of mathematics are not low agency, as I say, and I'm very open to that. I'm very amateur when it comes to math. I have no idea. Her talk, I think, is going to be dynamite. But anyway, in my current sort of simplified view, you have low agency simple things like mathematical truths. You have much more dynamic, much more complex patterns that I think we would recognize as kinds of minds, as behavioral propensities. And I can even give you some examples of things that are in between. There's some fun examples in between. So I think we are the patterns. We are not the physical interface. And mostly I think that the sciences that we have, which is, you know, the theory of algorithms and Turing machines and physics, all of that, I think all of those are really good theories of the front end interface. I think all of this is a thin client. I think the brain is a thin client. I think like all of this stuff is a thin client. It does some things, but the main show is on the other side. And I think if we don't understand that there's a lot of computation happening on the other side, then we're going to miss massive you know, massive amounts of interesting things.
Okay, so I have a last say argument on this question, which is Carl Friston. Right, I watched your discussion like 8 months ago with him today, and he mentions it there, but he mentions it a lot, and I actually talked with his co-author Alex Rorbia on mortal computation. So one of his claims is that no organism or no entity can be conscious without death, because that's the ultimate thing it has to care about, non-existence, going out of existence. So the way I understand these patterns in the Platonic space, they cannot die, can they?
I think that I know the work you're talking about, and I think that there are two kinds of patterns. And I hate, you know, more like I'm usually the person who hates binary distinctions, but I really suspect that there are. Oh, okay, let's talk about a spectrum of let's talk about thoughts for a second. So here's the spectrum. You can have fleeting thoughts. Fleeting thoughts, they come and they go and they're gone. It's like a simple wave in the water. They come, you know, eventually it's gone. Then you can have persistent thoughts. Recurrent thoughts that are hard to get rid of. And these are things that they stay around longer. They even do a little bit of niche construction in your brain. If they're depressive thoughts, they make it easier for you to have more depressive thoughts and things like that. They're kind of hard to get rid of. And then there's some other sort of controversial stuff in the middle. And then eventually you get to a personality fragment, like from a dissociative identity patient, right? So not just a memory pattern, not just, it has some ability to plan and some memory and some agendas and some things. And then you can have a full human personality that's like way more than that. And then you can, whatever the transpersonal, the thing is that people talk about, I don't know. So I think that some of these patterns, especially the ones that these guys were talking about, meaning computational systems and things like that, I think those patterns can die. Absolutely, they can die. I suspect that some patterns in that Platonic space, really the question is, does that space save state or not? Because if it doesn't save state, you can imagine that you project through a physical interface, the physical interface is destroyed, that's the end of that, you're gone.
Mm-hmm.
But you could also imagine that, at least for some certain kinds of patterns, which we know in media, there are self-perpetuating, whirlpools and the solitons and particles and things that kind of, you can imagine that the space saves state, and that after the physical interface is blown up, whether or not the system knew it at the time, the pattern's not actually gone. And you may or may not see it again. And I mean, obviously, this is like, I'm not inventing a new thing here. You've heard of this idea before. I don't have any definitive data yet to say anything like that. I'm just pointing out that I think it's perfectly fine to have some patterns that are temporary and that sort of go back to the ocean they came from, so to speak. And you might have other patterns that are very persistent on a very long time scale that maybe that are not as tied to the continued existence of a single interface, right? I don't see any reason why, because we already have an issue that I mean, there really aren't any permanent objects anyway, right? Your body is
No,
continuously
that's
changing.
exactly what I'm thinking about. I'm completely okay with the dying patterns. We can call like dynamic processes patterns. But then the actual immortality which bothers me, that on the top of it you have the prime numbers or whatever constants that seem immortal, and they don't seem to have to care about anything. That like what an agent is.
Yeah. Well, this brings back. I mean, this brings back another thing, which is, and Richard Watson and I have talked about this a lot. What is the prime imperative? So, standard evolutionary theory will tell you that it's survival, making copies of itself. And I think for a number of reasons that's unsatisfying and unsatisfactory, in fact. And if the whole point is not simply persistence, then the question, then the drive might be what? For example, I'll give you an example. Imagine a scenario, the butterfly caterpillar business, right? You train the caterpillar, it's going to become a butterfly. Now imagine the point of view of the memory itself, not of the caterpillar or of the butterfly, but of the memory itself. So I am this pattern that lives in this particular environment. Life has been good, but I can sort of see the writing on the wall. My medium is sort of starting to fall apart. Something's going to happen here. And let's say, just for a moment, that I realize that it's being refactored into a different kind of system. What do I know? Well, I know that if I remain exactly how I am, if I try to persist, and this is, I think, like one of these, Buddhist, was riddles, like these Zen riddles. If I try to persist the way I am, I'm absolutely going to die, because the butterfly has zero use for a memory of how to crawl around and eat leaves and this kind of stuff. I'm definitely not going to persist. What I could do, however, is change. Now, I could change, and in fact, that's actually what happens: is the memory gets remapped into a completely different, set of behavioral programs. So I could change, and continue to develop in some new form. I could, in fact, have a new life. In fact, I will have a higher dimensional life, because instead of crawling around in 2D space, I will now fly, through 3D space, whatever. So, like, I'm going to be, reborn in this amazing new embodiment, but I can't do it if I stay the same. And so I wonder, to what extent, right? Like, you see where I'm going with this. To what extent can we say that the imperative is not to survive and persist? The imperative is what? I don't know, but it might be to change, to grow, to explore, to, I don't know what it is, right? So, I'm skeptical of. I'm okay with the idea that there are certain things that are implied by having to persist as a unique individual, which I think is what Orobia and Friston are talking about. I think that's very, very clever, and I'm sure there's something to that. But I'm skeptical that the actual complete erasure from the world is what we're talking about here. I think it's actually much more subtle as to this question of who am I if I change, and what does it mean to change significantly? Am I still me? Like
No, I
that's maybe
mean
not
that's
the
exact. That was
question.
exactly the last question we explored last time: birth, death, and self-transformation or transcendence. So I'm completely with you again. Just not in the pattern space. It's more like our space. But in any case, just a last remark. When you talk about this way, I cannot not notice the convergence between you and Jonathan Pageau, who is talking about this for ages within Christian theology. And
Yeah,
it's like eerily similar to what you're saying. And he's also on the side of logos is calling the shots. So that was the first thing that get
yeah,
implemented, and multiplicity happens as you go down in the
yeah,
fractal, and unicity happens going up. And on the top of his theology, you have this eternal
yeah,
things like God,
yeah.
right?
Yeah, we just had a discussion with him
Ah,
actually
wow, beautiful.
recently. Yeah. John Vervecchia put us together.
It's
So we just
amazing.
had a discussion. I mean, the only thing I can say is I have zero claims about any of that. I don't know that. I'm glad that somebody else is doing this, but it can't be me. I don't know anything about any of those things. I only think that we have now gotten to the point where these questions have very specific outcomes. How you see these things change the way you do research, and we are doing things now that nobody has done before. Only because the standard view of things does not let you see those kinds of things.
Yes, no,
So
it's
so this
beautiful.
is yeah.
So let's talk about in the second part. Let's talk about AI a little bit, because a big question that everybody's thinking about is ChatGPT conscious, something
Yeah.
like that. So what do you think about that in light of all this sort of like ontology that you have?
Yeah, well, I have an even crazier view of that than the other stuff. I think. Here's what I think. What we are okay. The way I see what the computer science and science in general has done is to say, okay, look, it seems pretty clear that biochemistry does not tell the whole story of the mind. And most people, not everybody, but most people are willing to say that there's something else going on, in terms of cognition and consciousness and whatever, where you don't get the whole story from biochemistry. There's some other stuff we need to know. However, what we seem to have done is to, probably because we were desperate to some extent, we were, look, let's try to draw a little border in this world around something that really does just act the way our formal models say it does. All this other stuff, we know that all of our formal models of computation of whatever, they don't really work in biology. Everybody mostly knows that, but at least we can feel good that there is something that works exactly the way our formal models say they do, and that is machines. And machines just do what we have a theory of algorithms. And the machines do exactly what the algorithm says, no more, no less. No surprises. Okay, sometimes you get irreducible complexity, and sometimes you get some unpredictability. But machines are the things where our formal models describe the whole story. And I think that's never true. I think our formal models never tell the whole story. We cannot confuse our formal models for the thing itself. And so this is the part that everybody kind of hates. But the both the mechanist reductionists and
Sorting,
the
yeah,
organicists
the
hate this
sorting.
part. Well, that's right, because what I'm going to say is, yeah, you living things and we living things have some magic that is very important and is not well described by algorithms or machine analogies or any of that. But guess what? Is so do very minimal interfaces. Nothing is. And I have this like this joking title. I don't dare use it yet for any paper, but the title would be, you're made in God's image, but so is bubble sort. So don't get too excited. Meaning that the idea is that Yeah, there's something very special going on, but it goes all the way down. We are not unique in this. And the model system that we chose for this, and believe it or not, we have now, it will come in a few months, new papers, even something even stupider and simpler. But I thought we you know, for shock value, we started with something very simple, which are sorting algorithms. Okay. So bubble sort. So you look at regular old bubble sort, and then you find out that it has something that any behavioral scientist would recognize as delayed gratification. I don't know how long have sorting algorithms been studied? 60 years? Like I don't know, but many decades. Nobody seems to have noticed this, because if you look at the algorithm, you don't see anything like that. And then if you change it just a little bit to make it parallel, so that you know, it's parallelized, then you find out that, oh, it also does these other weird side quests that are also nowhere in the algorithm. In particular, it does something very interesting. Um, it develops a functional recognition of its own properties, and whether it's for any number in that array, whether its properties are different than its neighbors, and it tries to maximize actually like as clustering similarities. There is nothing in the code for this. You can see the code, unlike biology, where there's always some kind of quantum something hiding somewhere. This is new mechanisms. You know, this is, you can see the code. It's like 6 lines of code. That's it. There's nothing there. So now what we see is, and then I'm going to, this is a long-winded answer, but I'm going to tie it back to this whole AI thing. What we see is that even in the stupid bubble sort, it has competencies, not just unpredictability, not just complexity, but things that are recognizable to behavior scientists. It has minimal competencies that are nowhere in the algorithm. And it has side quests, meaning it does things that we didn't ask it to do. We didn't forbid it from doing that, but nor did we have any code for doing it. We don't spend any energy on doing it. In other words, it's doing things we didn't pay for computationally. There are no extra steps for it. It's doing it at the same time, and it's nowhere in the algorithm. So from this, it's a little bit like, you know what it's a little bit like? I've been developing this idea recently, steganography. You know, when you take a data set, like an image, you have an image of a cat, and there are a bunch of bits in that image that if you change the bits, nothing changes. You know, it's like a free degrees of freedom in the image that doesn't. And what people will do is they'll write secret messages in there. Either like if you're the artist, you can put your signature in there. If you're a spy, you can put the, you know, whatever messages in there. There's one rule. The rule is don't mess up the actual image, because if you mess up the actual image, people will tell you that there's something there, right? So I think this is what's happening. I think the rule is, yeah, you have to do what the algorithm says, but to whatever extent you can manage to do other things that don't screw up the main thing, you can do it. And that is where freedom, and this is something else. So I'm working up a theory of freedom that is neither randomness nor determinacy, but it's this like weird, it's like these this right. So here's my point about AI. Two things. I'll draw two conclusions. One is, if bubble sort has behavioral competencies that we didn't know about in decades of every CS 101 student studying these things, can you imagine what the massive code for a language model might be doing? Okay, if bubble sort has this, right? Like, who knows what the hell it's doing? And so that's the first thing. The second thing is, we are obviously not good at noticing this. So we need to develop tools, and this is one thing my lab is now doing, is trying to develop some tools to ask for intrinsic motivations. You know, we're very good, like with AI, it's very Skinner. We're all, you know, a reward function and you know, and all this kind of stuff. It's very Skinner. How about intrinsic motivations? What does this thing do that we didn't make it do? And this is for this reason. So people say, oh, you know, you're a computationalist because you think machines have consciousness. No, I'm an anti-computationalist. I think they may well, but it won't be because of the algorithm. It will be because of whatever they're doing in spite of the algorithm. Bubble sort is interesting because it does things in spite of the algorithm, not because of the algorithm. It's what's the space? What else is there between the chance and necessity? What else can it do, right? So I look at these model systems and I say, you know, asking it whether it's conscious is completely useless, because in biology, evolution made sure that the things we talk about are grounded to the things we actually care about, right? You have, I mean, yes, there are spies and there are, psychopaths and whatever, where the things they talk about are totally, total garbage. But mostly it's a pretty good guy, right? We've now created something where the thing we force it to do might have zero to do with what it actually wants to do. The thing that bubble sort does is not, that's interesting, is not sorting. It has nothing to do with sorting. And so I suspect that whatever properties language models have, whether I don't know what degree of cognition they have, we haven't tested this yet, but whatever degree they have, it's not going to be because they talk. I think it's going to have zero to do with the language. I think
Okay,
language
that's
might be a
good.
complete right. I think the language might be a complete red herring. You can ask them about their consciousness all day long. You are not going to see what the intrinsic motivations are. And we already know this from raising kids, that it's some combination of, like, if you force a kid to do math all day, okay, but what you're never going to find out that actually if you gave him some time, he might be drawing or playing soccer. I don't know, I don't know what the intrinsic motivation is going to be. Same thing with these AIs. Like, we can try to force them to do things, but there's also to me the most interesting part, and the part that we have to
The
be careful of
hallucinations, actually, yeah. I agree
well,
with you. I
hallucinations.
agree, and it's a very structured creativity that is not arbitrary. Yet, this is more like intuition or instinct that I'm trying to put some kind of argument behind it. But what I feel with current AI and technology in general, and it's very much inspired by all the nested agents that you're talking about, is that if I look at the biological organism like a kid, every level, cognitive level in the kid is somehow responsible for the existence of the kid. And it's not necessarily the highest level has some agency on that level, the cellular level has some agency on that level, but somehow they are all aligned and they agree that the kid should exist. And when I look at computational systems, what I have the layers, right? I have the silicon, the chip, I have the computer, I have the racks, I have the data center, I have the low-level language, the higher-level language, etc. And this looks like layers of abstractions that have some kind of homology with the organism, but they are not integrated in the sense that every layer is based on the previous layer, and if the previous layer breaks in any little thing, it will not work. Like I have a neutron hitting a chip in an airplane on my laptop, and I have to restart the laptop. And in that sense, the LLM on the top of it is not that. It's that the notion doesn't even exist that it would be responsible for the whole chain. Its existence depends on these layers of abstractions that are all separated in an information theoretical, in an agentic, in any sense that I can come up with. You see my point? So this is a very like fundamental difference for me between living and
That's certainly. Yeah, no, I agree that that's one. I mean, there are a number of major differences, for sure, between the way biology does things and the way we engineer. There are a bunch of differences. Some of those differences actually, I mean, we have discovered some new ones that I don't write about because I haven't decided yet whether it's like, I don't want to whatever extent I'm right. This will really potentiate the ability to make things that matter on a moral level, right? And I don't know that I want to be responsible for that. So I'm still sort of trying to figure out whether we should even talk about it in print. But I agree with you. There are many differences. But I will just I just come back to the same thing, that the interesting thing about all of these is, what is it doing in spite of the algorithm that we put in? And I think we're very bad at it as a community. We don't know, as scientists, we don't know how to find these things. The first thing we looked at it was this like with these things in these sorting algorithms, and what else is it doing that we are not smart enough to look at?
Or we don't care.
And we don't know to care. And in our new papers that are coming out later this year, we have even things that are simpler than those algorithms that are doing interesting things, right? So one of the most interesting things I think about that study with the algorithms is we figured out a way to let off the pressure a little bit for the algorithm. Now how can you do that? If you change the algorithm, then it's that was very hard. But there's a clever thing that we did, which is we allowed duplicate numbers. That's all. Just allow duplicate numbers in the data set. You don't need to change the algorithm at all. You just allow. So now you can still have all the fives together, then all the sixes, all the sevens. So what that allows you to do is to satisfy the algorithm, everything is sorted, but you can cluster as much as you want within each one, right?
Mm-hmm.
And when you do this, you see that the
Instead of
amount of
constructing,
clustering goes up. It goes up
amazing.
because to the extent that you allow this thing to do its own, right? If you tell your kid that you only have to spend half the time on math, guess where the other half is going to be? He'll do whatever he wants to do. That's what you're going to see. So I think we have to get much more clever about asking, what is this thing doing in the spaces, in the empty spaces between what we're forcing it to do? Not randomness and not deterministic algorithms, but that this crazy third thing. And I think that's where it really matches to this notion of the latent space. Because again, where do these things come from? They're not selected. They're not. It's not physics. They're coming from a structured space of possibilities that I think we have to start to understand.
Yeah, and I understand. I understand. Yeah, it's the only difference is that I don't think that that space has agency. But otherwise, I agree with you. There's a lot of structuralist way of thinking about how we come up with new ideas. For example, where there is some kind of space of knowledge and something is missing. Like it should be there because the structure, the space is like it's like some kind of symmetry, and we look at that thing and we recognize that it refers to something that is relevant. It's I don't know.
Yeah. I mean, we can make a continuum between your view and my view, and simply say that thoughts are thinkers to some degree. And so there are many things in that space that have very low agency. I mean, as long as if we can let go of the yes and no agency kind of thing, then we could say that, yeah, that space is full of stuff with extremely low agency. I'll give you a couple of simple examples, right? So like pi is greater than 3. That is a boring fact. That's like a rock. It just sits there, right? So in the Platonic space, that thing is like a rock. It just sits there. It's not going to do anything. That's it, right? Now think about and this is due to Patrick Grimm, his amazing work here. Think about the liar paradox. Okay, this sentence is false. If you plot it as a function of time, you get an oscillator, right? Not super smart, but not a rock either. It goes, like it buzzes. True, false, true, false, true, false, right? It's like sits there and buzzes. So what Patrick Grimm showed is that if you have collections of sentences that refer to each other. So sentence A might be, I am as 50% as true as sentence B. And sentence B is, I am false unless sentence A is 30% true or something, right? You make these things and they have very interesting dynamical shapes. They're fractal, in fact. And he has a couple of papers where he shows some fascinating stuff. So some of the patterns in that space are coupled differential equations. And we have shown that if you have certain kinds of coupled differential equations, they can do memory, they can do learning, they can do Pavlovian conditioning. So, it doesn't have to be that every pattern in that space has agency, but some of them can have some better sort of chops than others. And who knows how high it goes, right? That would be, that would be my softening of your view. I think it goes, all the action is over there, but that's
okay.
but you don't have to go that way. You don't have to go that far.
Okay. So last question is something completely different. I'm just wondering how your views of let's say this metaphysics and scientific views that changed along the years. How did it change how you live your life? So what is the most important thing that you can say that you do differently because of these thoughts?
Yeah, wow. I think that what's fundamentally impacted me most is the urgency of learning to recognize and communicate with really radical minds, radically different minds all around us. So this is an idea that, I mean, it's an old idea, right? But the old panpsychist version, or the animist, the pre-scientific animist version, doesn't really do the trick, because if you just say, there's a beautiful spirit under every rock, like that's nice, but it doesn't help you move forward. But now it's actually starting to seem possible to have principled, practical approaches for detecting and communicating with different, very radically different kinds of minds, and we're building some of those things in our lab. The interfaces to be able to talk to them. The obvious thing is talking to your cells and tissues, like that's for the biomedical side, that's obvious. But you can actually talk to many other much weirder things than that, and I think the ethical necessity, I mean, we're never going to get it, like, I don't think it's possible to get it exactly right, whatever that would mean, but we can certainly do better than we do now. And as just for me, as I move through the world, it's the fact that there are patterns in other spaces that, as I am one of these patterns, and the essential necessity to be able to recognize and communicate with them and relate to them ethically in some fashion, right? Some of higher agency, some of lower. This I think affects me greatly, and that's I think we now have a chance to really make a fundamental improvement in this as a species, and I suspect that this is it's an existential barrier for the species. I think moving forward into the future, I think a mature species has to have better ways to recognize and relate to a diversity of minds beyond binary machines, organisms distinctions. I am a human, this other thing is just faking, and these are pre-scientific ancient things that will not serve us well in the decades to come. And I think now I'm incredibly excited, but also kind of terrified of how difficult, how poorly how poorly prepared we are to do this, and how important it is, right? But I think we can. I feel optimistic that I think it can be done. Whether we will do it, I don't know, but I think we can. But I think it can be done.
Okay. And what kind of world would it lead to? Why is it important?
Well, why is it important? I mean, we as humans, I mean, I'm no historian, but my read of history is that we as humans are incredibly ready to treat beings differently over the tiniest of differences, right? We are very good at the in-group, out-group kinds of barriers. Okay, you have a slightly different, it's like the old Star Trek movie where, where the guy had a black and white face and the other guy had a white and black face, and they were like battling each other, right? Like yes, I mean, that made perfect sense. We're very good at that kind of thing. And all the more so are we good at making distinctions between, I am the product of random meandering mutation and selection, so I'm very special. You were designed by smart engineers. You're not real like me. I'm the product of evolution, right? So like these things, I think as a mature species, we cannot be an ethical mature species when we have no idea what we're looking at when we look out into the world. We don't have a good definition of agency. We make up these ridiculous brittle binary categories. I just think it's essential. Not to mention for the practical implications. Forget the AIs and the language models and sitting in a server somewhere. Forget that. How about when your neighbor has a bunch of electronic implants in their brain? Are you going to come over and say, let me take a measurement like 51% or 49%? Because let me tell you, as soon as you go over 51%, you are no longer human. I want proof of humanity. I'm not taking your writing product seriously. I don't think you have rights. I think you're a machine that has some human cells attached to it, right? All of this crap, is coming, right? So with cyborgs and hybrids and humans that are augmented and changed and all of this stuff, this is where it's going to hit first. It's gonna be like. I want a real human with standard organs and the same chromosomes. Like, I don't know, do you care about the organs and chromosomes? I don't. So that's gonna mean we have to ask, what do we really mean by human? What is it that we're proud of, right? And I think it has to do with our cone of compassion, really, our cognitive light cone in terms of compassion for others. It's not about chromosomes or organs or any of that. So that's why I think this matters going into the future.
Okay, well, it's terrific. Thank you very much, Mike.
Thanks, Blash. Always great to see you.
Thank you.
Yeah, I got to run, but thank you. And happy to chat anytime.
Okay. I'll see if topics arise. Thank you. Bye.
Yeah. There's plenty more. All right.
Bye.